Find the sum to infinity of the series where absolute value of x less than 1. Let us begin. Now here in this problem, we are being provided with an infinite series whose first term is 1, then the second term, that's 3x, the third term is 5x squared, the fourth term, that's 7x cubed, and this goes on all the way up to the infinite number of terms. Now this particular series is neither an arithmetic series nor a geometric series. It's not an arithmetic series because it does not have any common difference, and it's not a geometric series because it does not have any common ratio. However, this particular series is composed of an arithmetic and a geometric sequence. For instance, if we consider the sequence 1, 3, 5, 7, the sequence having these terms which are the constant coefficient. So these sequences are going to be in, these are the terms of the sequence are going to be in arithmetic progression. And if we take from the first term 1, then the next term x, third term is x squared, fourth term is x cubed, and so on. This particular terms are going to be in geometric progression. Now if they're in geometric progression, then the first term a, that will be 1, the common ratio that's defined by taking any term in the sequence and dividing it with the previous term to get it to give us x. Now this is a arithmetico-geometric series because it is composed of these two sequences. One will be in arithmetic progression and the other will be in geometric progression. Now to find out the sum, what we'll do, we will suppose that let s infinity, so this is going to represent the sum to infinite terms 1 plus 3x plus 5x squared plus 7x cubed, and so on. Now what we'll do, we will consider the common ratio of the geometric progression, which is x in our case, and we're going to multiply it with each terms of the sum up to the infinite terms. So we have x multiplied to each terms of sum up to infinity. So x times 1, the first term, that's going to give us x, but we're going to write it below 3x. Next term will be 3x of s. So when we multiply with x, that becomes 3x squared. Then we have 5x cubed, and this is going to go on up to infinite number of terms. Now what we'll do, we're going to subtract s up to infinite terms, and from here we're going to subtract x times s infinite. So this will be equals to 1 plus, we have 3x minus x, that's going to be 2x. Then added to it 5x squared minus 3x squared, that's 2x squared. Added to 7x cubed minus 5x cubed, that's 2x cubed, and this is going to go all the way up to infinity. Now what we'll do, we're going to keep the first term as it is. Let's keep it as 1. Now starting from the second term 2x all the way up to the infinite number of terms, this is going to be a geometric series. Now this is a geometric series because here for this series, the first term a, that's 2x. We have the common ratio, so we can take any term and divide it by the previous term, that gives us x. So that means the common ratio is x, and we know the sum to infinity or sum to infinite number of terms of any geometric series is given by a over 1 minus r. So using this value, we're going to get 2x divided by 1 minus x. And on the left hand side, if we take s up to infinite number of terms as the common factor, this will get multiplied to 1 minus x. Now what we'll do, we'll divide both sides with 1 minus x. So as up to infinite number of terms, that will be 1 over 1 minus x added to 2x over 1 minus x whole square. We can combine them. So we have 1 minus x whole square as the common denominator. So, and in the numerator, we have 1 minus x added to 2x, so that gives us 1 plus x. So this is going to be the sum up to infinite terms of the given series 1 plus 3x plus 5x squared plus 7x cubed, with the condition that x is less than 1.